Today I'm going to talk about linear and angular velocity. The measure of how fast the position of P is changing is called linear velocity. So if I have a point on my circle, the speed at which it's traveling around my circle is referred to as linear velocity. And we abbreviate linear velocity with the uppercase letter V, and that is the distance you travel over time. Or another measure of it would be arc length over time. As a point moves along the circle, a rate OP rotates about the origin. So I'm going to draw myself a circle. And I have this point P here. And if I think about that as being my origin, I have a ray that is rotating around my circle. The speed at which that angle changes is called angular velocity. So and we abbreviate this with what looks like a W, but it's actually a lowercase omega. And that is the angle, the change in your angle in radians. It's always measured in radians over the amount of time it takes. So it's always measured in radians per time. Now, you can think about the arc length, S, as your radius times your angle in radians. Remember that formula we talked about before? All of these problems are big unit conversion problems. So let's take a look at our example. The human wrist rotates 90 degrees in 0.045 seconds. And it's while holding a tennis racket. I want to know the angular speed. Remember that angular speed is always measured in radians per time. So we're going to start with degrees per second. So we have 90 degrees over 0.045 seconds. I'd like to change the degrees to radians. So I want my degree units to be on the bottom. And I want to change it to radians. And in pi radians, I have 180 degrees. Or I could say in 2 pi radians, I have 360 degrees. It doesn't matter so long as you get, as long as you have the units right. The number of radians per the number of degrees. And then we multiply across, and when that happens, the degrees will cancel, and I'll end up with radians per second. So this would be 90 pi over 0.045 times 180. Now, we're going to put this in the calculator, but I want you to be very careful about that. This fraction bar tells us what's implied is everything in the numerator is done first and everything in the denominator is done second, and then we divide last. So what is here that doesn't really show up is an extra set of parentheses. So we're going to put in our calculator 90 pi, and we are going to divide by 0.045 times 180, but that needs to be in parentheses. And this is approximately 34.9 radians per second. Now, if I want an exact answer, I don't multiply through by pi. This is my approximate. The exact answer is what I would get if I did 90 divided by 0.045 times 180. And remember that, again, that needs to be in parentheses. And then in my calculator, it can convert that to a fraction. And that is 100 over 9, and the pi comes along for the ride. Again, that's radians per second. Okay, now let's take a look at the next example. It says if the radius from the tip of the racket to the wrist is 2 feet, find the speed of the tip of the racket. So what we're looking for here is linear velocity. And again, it is going to be a unit conversion problem. I'll show you how that works. So I have 100 pi radians per 9 seconds. I would like to get a length per second because linear velocity is how far my point moves along my arc and over the length of time that takes. So I want my radians to cancel. Now, in 1 radian, I have 1 radius of arc length. So I have 2 feet of arc length. And when I multiply across, I will end up with feet per second. So this is 200 pi over 9 feet per second. Now, let me explain again for those of you who may have forgotten, when you're talking about radians, in 1 radian, I have 1 radius of arc length. That's how it's defined. So this arc length here is the radius of my circle. So that's how we make the conversion from angular velocity to linear velocity. And again, 200 pi over 9 is an exact answer. If I want an approximate answer, I would multiply through by pi. And that is approximately 69.8 feet per second. Okay, in our next problem, I have a wheel. It's turning at a rate of 48 revolutions per minute, and I want to express this angular speed in radians per minute and also radians per second. And again, I'm dealing with unit conversion. So I have 48 revolutions in 1 minute. I want my revolutions to cancel out and be left with radians. So my revolutions need to go on the bottom and my radians need to go on top. In 1 revolution, I have 2 pi radians. So now when I multiply across, what I'll end up with is radians per minute. So I take the 48 and multiply by 2, and that gives me 96 pi radians per minute. Now, the next thing I want to do is express this in radians per second. So I have 96 pi radians in one minute. Now I want my minutes to cancel out. So my minutes are going to go in the numerator, and I want to end up with seconds. So in 1 minute, there are 60 seconds. So now, when I multiply across, I end up with radians per second. So I'd end up with 96 pi over 60. Now I want to reduce the 96 over 60. And that is the same as 8 over 5. So it's 8 pi over 5 radians per second. And again, both of these are exact answers. If I want an approximate answer, I just multiply through in my calculator. So when I look at the 96 pi, I would just multiply 96 by pi. and that is 301.6 radians per minute. Again, that's approximate. And in my last example, I would multiply 8 pi and divide by 5 and get 5.0 radians per second. Let's take a look at this problem. It asks the second hand of a clock is 10.2 centimeters long. Find the linear speed of the tip of the second hand. So what this is giving you is the radius. So if you picture a clock, and you've got the second hand there, the length of it is the radius, and we want to know how fast that tip right there is moving along the arc of the circle. So the first thing I want to find out is how fast my angle is changing around the circle. So I'm going to find my angular velocity first and then convert it to linear velocity. So my angular velocity is the number of radians, 2 pi, over the length of time that it takes that second hand to travel all the way around the circle. So this second hand is going to go around the circle in 60 seconds. So now I want to take my radians and I want to convert it to a length. Remember how radians relate to arc length. In 1 radian, I have 1 radius of arc length. So I have 10.2 centimeters. So when you multiply this through, you will end up with centimeters per second. So this is 2 pi times 10.2 over 60. Now, in my calculator, I'm going to multiply the 2 times the 10.2 and divide by 60. And then I'm going to reduce the fraction in my calculator. So 2 times 10.2 divided by 60. And then if I convert by pressing math, enter, enter, I get that that's 17 over 50. So this is 17 pi over 50. And again, that is centimeters per second. The units in this section are extremely important. Sometimes it will ask you for a specific unit. In this case it didn't, so I got to choose. But if I'd like to change that to centimeters per minute, I could. The way I would do that is do 17 pi over 50. This is centimeters over seconds. And if I want my seconds to cancel, I'd have my seconds in the numerator and my minutes in the denominator. And in 1 minute, I have 60 seconds. If I were to multiply that across, I'd end up with 17 pi times 60 over 50. And again, in my calculator, I'm going to multiply 17 times 60 and divide by 50. And then I'm going to convert that to a fraction. And that is 102 over 5. And the pi comes along for the ride. And again, that is centimeters per minute. If you want approximate answers, you take each of these and you multiply through by pi. 17 pi divided by 50 gives you approximately 1.1 centimeters per second. And over for centimeters per minute, 102 pi divided by 5. That is approximately 64.1 centimeters per minute. Again, all of these are big conversion problems. I'd like you to try this next problem. It says a lawn roller with 10-inch radius makes 1.2 revolutions per second. In the first part, I'd like you to find the angular speed of the roller in radians per second. And in the second part of the problem, it asks you the speed of the tractor that's pulling the roller. So that's another way of asking you what the linear velocity is on the edge of that lawn roller. Press pause on your video, and when you're ready for the answer, press play again. Okay, here's my answer. So in the first part, it says, what's the angular speed of the roller in radians per second? I have 1.2 revolutions per second. I need my revolutions to cancel. So if the revolutions are on top, the revolutions to get it to cancel need to go in the denominator on the bottom. And in one revolution, I have 2 pi radians. We multiply across. 1.2 times 2 is 2.4 pi. And again, this is radians per second. Radians per second. That's what it asked for. In part B, I want to know the linear velocity of the tractor. So I need a unit per time. I have the 2.4 pi radians per second. So to convert radians to arc length, I know in 1 radian, I have 1 radius of arc length, and my radius is 10 inches. So multiplying across, I find that that's 24 pi inches per second. Now, did it tell me what units to put? It did not, but I just wanted to show you if I want to convert to a different kind of unit. We usually don't think about tractors going in inches per second when we think about speed. So I converted it to miles per hour just to get a sense of what that would be like. So I started with my 24 pi inches per 1 second. I wanted my inches to cancel. I don't know how many inches are in a mile, but I do know how many inches are in a foot. So the inches went on the bottom, the feet went on top, and 1 foot I have 12 inches. Then I want my feet to cancel this way. And in 1 mile, I have 5,280 feet. So now if I were to multiply across, you can see that my inches would cancel and my feet would cancel. So if I stopped right there, I would have miles per second, but I'd like miles per hour. So the next thing I did was I changed my time. So I had seconds on the bottom. So seconds went on top. And then my minutes went in the denominator. So in 1 minute, I have 60 seconds. And then I still wanted hours, so my minutes went on top, my hours went on the bottom. In 1 hour, I have 60 minutes. And then I multiplied everything straight across. Remember, all of these, you have to divide by each of the things that are in your denominator. And that ended up with 15 pi over 11 miles per hour, and that's approximately 4.3 miles per hour. So in other words, you don't want to get stuck behind that tractor. Okay, I have one final problem for you to try. If a car is traveling at 60 miles per hour and the radius of the wheels is 1.5 feet, find the revolutions per minute the wheels are rotating, and then it asks what is the angular speed of the wheels in radians per minute. Give this a try and press pause. When you're done, press play and we will discuss it. So here's my solution. The first thing actually we had to do was convert to an angular speed. It told me that my car was traveling at 60 miles per hour, so that's where I started. That's actually the linear velocity, 60 miles per 1 hour. So I want to get radians per minute. So I first converted my time to minutes. So my hours went on top, my minutes went on the bottom. In 1 hour, there are 60 minutes. So Now, if I were to multiply across before doing anything else, I would end up with miles per minute. Now, I want radians, and in order to convert to radians, I need to have the radius play a part of that. So I first convert miles to feet because my radius is in feet. In 1 radian, I have 1.5 feet. In 1 radian, I have 1 radius of arc length. So converting my miles to feet, my miles went on the bottom, the feet went on top. In 1 mile, I have 5280 feet. And again, if I were to multiply across at this point, I would end up with feet per minute. Now I want radians per minute. So in 1 radian, my feet go on the bottom to get the feet to cancel. In 1 radian, I have 1 radius of arc length, or 1.5 feet. So the feet now will cancel, and when you multiply across, you get radians per minute. Now that's my angular velocity in radians per minute. Now I would like to take that and convert it so that I know the revolutions per minute that my wheels are turning. So I have 3,520 radians per 1 minute. I want to convert these radians to revolutions. So my radians go in the denominator, my revolutions go up top in my numerator. So in 1 revolution, I have 2 pi radians. Now again, be very careful. If you were to plug this directly into your calculator, you've got to remember that that pi is in the denominator. It needs to be in parentheses. If you simply enter 3,520 divided by 2 pi without the parentheses, what it does is 3,520 divided by 2, and it multiplies by pi. We don't want to see that happen. So again, if you want to convert to an approximate answer right away, you got to remember those parentheses. I did not. I got an exact answer, so I did the 3,520 divided by 2. That was 1,760 over pi, and again, that's revolutions per minute. And then I plugged it into my calculator to get an approximate answer. So that ends the examples that I'm going to do for today. Take a look at the assignment online. Have a great day.